Hello everybody, getting ready to do section 22, probability lesson for SAP math level 2 preparation. And for today's lesson you have 10 points, so go into your notebook, have notebook guides, have those out. And then 16 points, so go into your classwork sheet, have that out as well. Name, date, period in my classroom if you're online, or if you're online, put your due date here. Go right in for today's lesson here. When an experiment has an uncertain outcome, probability provides a measure of how likely an outcome or collection of outcomes is. Tossing a coin, rolling dice, drawing cards from a standard deck, and picking marbles out of bowls are simple examples of experiments that illustrate important aspects of probability. The results of an experiment are called its outcomes. A coin toss has two outcomes, heads and tails. Tossing two coins has four outcomes, heads, 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 tails, tail, heads, and tail, tails. Rolling a single die has 6 possible outcomes, while rolling a pair of dice has 36 possible outcomes. Drawing a single card from a standard deck has 52 possible outcomes. Drawing 5 cards from a standard deck has a 52 over 5, 52 choose 5, has 2,598,960 possible outcomes from say a 5-card poker hand. The set of all possible outcomes of some experiment is called a sample space. An event is a subset of the sample space, a collection of possible outcomes. The probability of an event is the number of outcomes in the event, favorable outcomes, divided by the number of outcomes in the sample space. So that would be a probability there. Let E be an event. The possibility of E be the set of outcomes that are not in E, or the complement of E, say. So tilde E would be the set of outcomes that are not in E, meaning your favorable outcomes. And the probability of E represents the probability of E. So P of E in the parentheses would be the probability of E. So when we have 0 less than or equal to the probability of E less than or equal to 1, that'd be a probability there. And then the probability of not E would be 1 minus the probability of E. If probability of E equals 0, E is called the impossible event. If probability of E equals 1, E is called the certain. So there's certainty, and then there's no way E would happen. So if a card is drawn from a standard deck of 52 cards, what is the probability of the event that the card is a picture card? What is the probability of the event that the card is a space? So we have two questions here. There are 12 picture cards in this standard deck, so if one card is drawn, the probability that it is a picture card will be 12 out of 52. The probability that it is a spade is 13 out of 52 because the deck has 13 spades. So that kind of answers both those up there. B, if a coin is flipped twice, what is the probability of event 1 head and 1 tail? Well, since 2 of the 4 possible outcomes have 1 head and 1 tail, the probability of this event is 2 over 4, which would be reduced to 1/2, 1 over 2. And then C, what is the probability of getting a sum of 7 when 2 dice are thrown? So when 2 dice are thrown, the outcomes of rolling a pair of dice can be more readily understood by assigning colors to the dice. Say one's red and one's green. An outcome of throwing a pair of dice can be represented by an ordered pair where the first element is the side of the red die facing up and the second is the side of the green die facing up. Thus, 32 signifies, or rather 3-2 signifies a 3 on the red die and 2 on the green, while 2-3 signifies 2 on the red and 3 on the green. Since there are 6 faces on each die, there are 6 by 6 possible outcomes in the sample space. The outcomes that have a sum of 7 are 6, 1, 1, 6, 5, 2, 2, 5, 4, 3, and 3, 4. Therefore, the probability of getting a sum of 7 will be 6 out of 36, or 1 out of 6. Probability questions can be asked about two events A and B. Questions on the level 2 mathematics subject test cover the following 3 ways of combining two events. Probability of A disjointed from B. The probability of either A or B occurring where A disjoint B is called the disjunction of A and B. Probability of A given B, it means the probability of A occurring given that B has occurred. This is called a conditional probability here when you have this vertical line here in between two possible events. And then the probability of the junction of A and B, the probability of both A and B occurring where A and B is called the conjunction of A and B. So these are like different kinds of situations within probability here with these symbols that could very well be asked on the test. If two events have no outcomes in common, they are called mutually exclusive, and probability of A disjointed from B would equal probability of A plus probability of B. So since they're not dependent on each other. If two events have outcomes in common, these outcomes would be double counted, resulting in the more general formula of probability of A disjoint B would equal probability of A plus probability of B minus the probability of A join with B. Note that A and B are mutually exclusive if and only if the probability of A join with B equals 0. So think about that one for a while. Okay, so D, question D, in a group of 40 students, 23 take the AP Psychology test, 18 take the AP Calculus class, and 8 take both classes. What is the probability that a student takes AP Psychology or AP Calculus? So let A be the event that a student takes AP Psychology and B be the event that a student takes AP Calculus. Then A join with B represents the event that a student takes both courses. In the formula above, probability of A would equal 23 over 40, probability of B would be 18 over 40, and probability A join with B would be 8 over 40. Therefore, probability of A disjoined from B would be 23 over 40 plus 18 over 40 minus 8 over 40 would equal 33 over 40. So that would be your answer to this question up here. Taking both AP Psychology and AP Calculus are not mutually exclusive because the probability of taking both courses is not 0. So there you have it. E, in a throw of 2 dice, what is the probability of getting a 7 or an 11? So let A be the event of throwing a 7 and B be the event of throwing a 6-5 or a 5-6 for a total of 11. Since these events are mutually exclusive, the probability of A disjoint B would be probability of A plus probability of B would be 6 over 36 plus 2 over 36 would equal 8 over 36. In conditional probability, the sample space is reduced to the set B rather than the set of all outcomes, and the favorable outcomes are those in both A and B. So A join B, probability of A given B is the probability that A occurs given that B occurred. This results in the formula probability of A given B would equal the probability of A joined with B over probability of B. Multiplying both sides of this equation by probability of B produces the equivalent formula of probability of A joined B equals probability of B times probability of A given B. If the probability of event A occurring does not depend on whether event B occurs, then A and B are said to be independent, and probability of A given B would equal probability of A. Thus, if A and B are independent events, then the probability of A joined with B would equal probability of B times probability of A. Seems to make sense. So F here, if you can draw 2 marbles in a sequence from a ball with 10 black and 4 yellow marbles, and replace the first marble before picking the second, what is the probability that both marbles are yellow? So since there are 14 marbles all together and 4 are yellow, the probabilities that for the first marble are 4 out of 14 for Y, and then 10 out of 14 for B. So for Y would be yellow, then B would be black. The return of the first marble makes the first and second picks independent, so the second pick has the same probabilities. Use the formula, the probability of A joined B equals probability of A times probability of B, where A and B are both yellow. To find probability of Y joined with Y equals 4 out of 14 times 4 out of 14, that would come to 16 over 196 for them both to be yellow. And G here, the scenario is the same as in example F, but this time the first marble picked is not replaced. What is the probability that both marbles are yellow? So if the first marble is not returned, the first and second picks are not independent, so we must use the formula probability of A joined B equals probability of A given B times probability of B. In this case, probability of yellow equals 4 over 14 as before, but probability of yellow given yellow would equal 3 over 13 now, because there are only 13 marbles left, of which only 3 are yellow. Therefore, the probability of yellow joined with yellow equals probability of yellow times probability of yellow given yellow would equal 4 times 14 multiplied by 3 over 13 would come to 12 over 182, which simplifies to 6 over 91. That would be the different kinds of probabilities there. So H, if the probability that John will buy a certain product is real over 5, that Bill will buy that product is 2 over 3, and that Sue will buy that product is 1 over 4. And if their decisions to buy are independent, what is the probability that at least one of them will buy the product? So this is a good example for using complements, since the question asks for the probability of at least one, find the probability of none, and subtract that from 1. The probabilities that John, Bill, and Sue don't buy the product are 2/5, 2 over 5, 1 over 3, and 3 over 4, respectively. Since their decisions to buy or equivalently not to buy are independent, the probability that none of them buys the product be 2/5 times 1/3 times 3 over 4 would equal 1 over 10. Therefore, the probability that at least one of them buys the product would be 1 minus 1 over 10 would be 9 out of 10. So therefore, the chances are 9 out of 10 that one of them buys the product due to this calculation here. And then I, 2 dice are thrown. Event A is the sum of the 2 dice is 7. The sum of the 2 dice is 7, so 2 dice are thrown. And event B is at least 1 die is a 6. Are A and B independent, so we have 2 dice are thrown. and we have 2 dice are thrown. From example C, probability of A is 6 out of 36 up here. See, 6 out of 36, there would be 6 different chances of having a sum of 7. Event B includes 1 and 6, 2 and 6, and then 6 and 6, etc. So 6 and 1, 6, 2, 6, 5. So probability of B would equal 11 out of 36. There'd be 11 possibilities of event B here. Event B is at least one die is a 6. So there will be 11 possibilities of that. Only the two throws, 6 and 1, and 1 and 6 are in event A given B. So probability of A given B would equal 2 out of 36 in that situation there. So probability of A, or rather probability of B multiplied by probability of A would be 11 over 36 times 6 over 36 equals 11 over 216, which does not equal 2 over 36. So therefore A and B are not independent. They would not be independent.